All right, the last part of chapter one starts you to think like a scientist. And that's where we go over something that I know you've seen a million times before, a scientific method. Your scientific method is this logical approach to the solution of scientific problems. And you might be thinking, oh, heck, not again. We do this every single year. But it's really important that you say, oh, heck, because the O, the H, the E, and the C helps you think of the four main parts. Okay, you make observations, you use your five senses, your hypothesis is made. This word educated always bothers me because it's based off of what you see. Okay, so you observe things and then you make your hypothesis because of it. Then you test your hypothesis through experimentation. Okay, so you design some sort of experiment so that you see what one thing is changed, and then you come up with a conclusion. What did you find? And that conclusion can either be a scientific theory or a scientific law. And we'll get into the difference of those things in a little bit. All right, but you have been using the scientific method your entire life, from learning to walk, um, from crawling, from riding a bike, all the way to, everyday stuff like when you don't feel well. If you don't feel good, how do you know? You make observations. Ugh, my throat hurts, Mom. My head's all stuffy and I got a runny nose and I just don't feel good. Hopefully you don't have COVID. All right, but those are observations that you make. Okay, so when you have those symptoms, you make a hypothesis. I think I'm sick. If it's a really sore throat, you might think like, oh man, do I have strep? That's supposed to be a really bad sore throat. I've got strep like 3 times, and I used to think it was a joke. I didn't get it as a kid. I thought all of you guys were like lying, but let me tell you, it is no joke. It is really, really a bad sore throat. It feels like you're like swallowing razor blades. Ugh, it's awful. So, what do? You can't just, sit there. So, you test out your theory. You go to the doctor, where guess what? They make observations. They test your blood, or they do a throat culture, that giant, huge swab. They do experiments. They grow the bacteria or the virus and they see what's in there, depending on what your symptoms are. And then what do? They draw some sort of conclusion. So, depending on the results, you might either just have a cold, you might have the flu, you might have strep throat. Hopefully, you don't have coronavirus. Um, but there is something that they do with that. Okay, if you have strep throat, they can use antibiotics because it is a bacteria. But you can't use antibiotics for a cold, so you're just going to have to wait. All right, very sad, but we don't have antiviral medication like that because it mutates too quickly. All right, so when you come up with these conclusions, what can we do with them? All right, well, they basically go into theories and scientific laws. So, what's our difference? Okay, a scientific theory is a broad and extensively tested explanation of how we got what we got. Okay, it can never ever be proven. All right, but it is going to explain everything that we see and it has supporting data. All right, so the big example that we use for this is our Big Bang Theory. And this is more than Sheldon Cooper um, banging on Penny's door. Penny, Penny, Penny. All right, the Big Bang Theory is the origin of our universe. So it all started with the Big Bang. We can't ever go back. It is impossible to go back. It's possible that something else will do that to explain everything. But basically, what they do is they measure the distance between stars and they measure how the light moves, and they can end up actually seeing that our universe all started with this great big huge ball of matter and it travels outwards. It expands. All right, and because it expands, that's where we end up getting these teeny tiny other little galaxies that cool off. And, um, our zone right here is where we're far enough away from this um, original blast, and we can end up seeing that life has formed here. All right, can we go back and see what the Big Bang, is that what actually happened? No. Okay, unless we have a time machine and, maybe pull off a time heist. But no, we can't do that. All right. So we also have these scientific laws. Laws are going to be these concise statements, these little summary of results of our observations and our experiments. They describe the natural phenomena without attempting to explain it. They use lots of mathematical relationships. Have you seen the DMV triangle before? Density equals mass over volume. We're going to use this um, calculation a lot, all right, so that we can solve for mass and volume and density seamlessly. And I'll teach you lots and lots of different ways to get in and around there. We've all seen E equals mc squared. That's Einstein's famous experiment where E stands for our energy, m is the mass of a particle, c is the speed of light, and we're going to square it. The speed of light is a constant. Okay, that's going to be 3.0 times 10 to the 8th meters per second. All right, and you've all seen area equals pi r squared. All of these are scientific laws. All right, and don't forget, pi's are, round, not squared. But we in class will go over this lovely phenomena with lycopodium and how forest fires actually spread. All right, so I have a little plate on the table, and I put a pile of tree pollen, which is what lycopodium is. Okay, it's that lovely yellow tree pollen that you see. And I get a candle, and I light the candle, and we see what happens when I put the candle to the pollen and when I put the pollen to the candle. And that's something you got to see in real life. All right, so lastly, how do we study for a subject where we study everything? Well, here is going to be the secret to success. Chemistry builds on itself. Okay? It is constantly referring to what we just went over. In fact, as chemistry teachers, reorganize the chapters of our book because it doesn't really make sense the order in which they do it. All right, so we kind of reordered it so that it really builds on itself. So if you don't catch it the first time, we're going to kind of loop back and talk about it in chapters before and before and before. But you got to pick up on it. You can't just say, like, I'm just going to cram it the day before. All right, if you write things down in chemistry that relate to your life and you actually see what's going on, all right, it really is helpful. All right, so I have audits and stuff in class. You use your textbook, not Google. Okay, Google has different definitions for things like precipitation. You might think that's rain. Precipitation in chemistry is when a solid forms in a solution. All right, so that's something totally different than it raining. I highly, highly suggest you get flashcards and you write down your different keywords or your ions or your symbols. And it's way different than using online flashcards. There's something about the muscle memory of you writing and reading and saying and talking that is different than just typing it in. We're going to do lots of different kinds of practice problems. Okay, if you just watch me do it or watch an example, it's not the same as actually using some pen and paper and writing it down, solving. We're going to use lots of algebra here. If you're not good in algebra, that's okay. I will help you with it. I will give you all my little tricks and um, pro tips for everything that we do. And actually using your calculator. You need a calculator. Probably the second most important thing that we use besides our periodic table is going to be our calculator. And if you do those things step by step by step, you'll be okay. Okay, tests and quizzes are going to be a marathon, not a sprint. Okay, cramming is never a good idea. It's cumulative. All right, what we do with chapter one will be on the midterm in January, and it'll be on the final in June. This is stuff that you will see. All right, so hopefully we go on this chemistry journey together and we have a great time seeing where everything is in our life. All right, ta ta for now.